So this is the first AP Physics Electrostatics cyber school video on YouTube, and just to start with, everyone should have watched the tape trick. That was a video also in my list, and you should have tried the tape trick on your own. 2 pieces of tape's all you need, and some objects around your house, and to see what the 2 tapes do after they're charged in various circumstances. And then what you're supposed to do is to put your comment at the bottom of the video, the tape trick video. Now you can do that one whenever. Sometime today would be a good time to do it. So with this next one, this isn't a real long video, but I want to show you how to do some physics with 2 objects that are repelling each other. This is a real kind of a standard AP Physics problem. So we're going to take a look at this. And then afterwards I'll show you something real with balloons doing a very similar thing. And then finally I'll give you a little challenge at the end that you're supposed to write your answer to in the comments. And then I'll reveal the answer to you later on next time we have class, and we'll see who was actually right about that. Okay? All right, so let's get started then. If we have 2 objects that are hung up so that they're repelling each other, what you're seeing right here, let me hold this so it's better. Okay. What you're seeing is 2 objects that are repelling each other, and so there's an angle between them. So I have this set up so there's about 0.1 meters between the objects and 0.3 meters long is the string, saying each object is about 0.1 grams. Okay. So in this situation, there's a free body diagram you could draw for it. That's indicated there. There's tension in the string, it's holding it up. There's an electrostatic force. That's, of course, what's making the 2 things repel each other. And then there's the weight, of course, it's downward. So if you know what the weight of the object is, that's mg. In this case, that would be about 9.8 times 10 to the minus 4 kilograms, because it's 0.1 grams. And you know the dimensions of the triangle. It should sound kind of familiar to you that we're going to use trig functions to be able to figure out what the electrostatic force is. So that's what I've done on the side over here. You can see it where that calculation for Fe is 1.66 times 10 to the minus 4th newtons. And then finally down there, what I'm doing is I'm using Coulomb's law at the bottom to show you how to calculate exactly how much charge is on one of those 2 objects, assuming they're charged identically. So we just use Coulomb's law. We use that known electrostatic force. We use the distance between the centers of the objects, and then we can calculate that charge, which in this case I have at the bottom is about 1.34 times 10 to the minus 8th coulombs. So, like I said, that's a kind of a standard physics problem. You'll see that in your book as well. And there's some variations of it that you see on the test, whether you calculate the charge that's on the objects, or you're calculating, what the angular separation might be. In any of those cases, it's free body diagram, it's an equilibrium, and you're able to solve for the thing that you're missing. Okay? So what I want to show you right here is 2 balloons that are basically in the same circumstance right now. So let me try to get this right here. So these 2 balloons right here, the blue one and the green one, they're both separated by about, this is actually about 10 inches right now. And the strings, as they go up towards the lights, they're about 30 inches long. So their proportionality is just about exactly what the problem was that I showed you. So about 10, that was 10 centimeters of separation. This is 10 inches, and then about 30 centimeters of string. So the proportionality is almost exactly the same as the problem that I showed you before. So if you knew the masses of the balloons, which are off of, they're not quite maybe like 3/10 of a gram, something like that, each of these balloons are, that you can redo the problem and you can figure out what the charges are on each of these balloons. But the thing is that the answer is going to end up being very close to the one that I just gave you. Okay. So now here's your challenge, and again, what you need to do is to make a prediction about this in the comments section below this video, And then what I'll do is I'll look at all those comments later and I'll figure out who was right. Okay, so here's what the challenge is. What I'm going to do is, you can see that these two balloons are hanging up here by the strings, right? If I bring my hand over to one, let's say the green balloon, right, and I pull it with my hand as far up as I can pull it, right, far up towards the ceiling as I can pull it, will I be able to pull it to separation, an angular separation from the vertical of between 20 and 30 degrees, 30 and 40 degrees, 40 and 50 degrees, 50 and 60, 60 and 70, 70 and 80, more than 80 degrees of separation from the vertical. Okay, so that's what you have to do. You have to make a guess about that. It's kind of like the way we do these in class, and then I'll show you some verification of this in a couple days. But what you have to do now is in the comments section, put your prediction down there for that. Okay, thanks.